Hi, I'm Elliot, and I'm presenting with Martin and Philippa from Nextjournal, and we're talking about live programming, a live programming environment, an experience report, which is the paper we made for Live, that you can find at live24.clerk.vision. And we also made this with some other folks from Nextjournal, Jack and Andrea. It switched on me. So at the start of the summer, Jack invited me to come out to Berlin and work with the Nextjournal folks. And I got to learn about Clojure and Clerk and see how Martin and Philippa and others at Nextjournal live program every day in Clojure using REPL-driven development. And I also got the amazing opportunity to learn about the automotive logistics industry. So yeah, Clojure, in Clojure, the way people do live programming is called REPL-driven development, which is like a fine-grained type of getting feedback on your program where you evaluate individual expressions. And it's a part of the culture of Clojure programming. And the folks at Nextjournal work on a complementary system to this style of live programming called Clerk, which allows you to apply rich and moldable viewers to your data and apply incremental computation to your Clojure files. So yeah, Nextjournal's working with clients in the automotive logistics industry, and they have a system that generates a ton of data about cars, and the users have a need to understand and explore and generate insights from their data. So we wanted to submit something to Live, and we also wanted to build a tool for our users. So we decided the project we want to work on together is a live programming tool similar to Thomas Petracek's The Gamma and Histogram, a report builder, so that users can explore their car data. In reading The Gamma and Histogram, we liked the framing that Thomas had, where he shifts from talking about programs to talking about how we program. So the focus of our paper and this talk is not about what we built. It's about how we built it in a live programming sense. But first, I want to show you what we built before we talk about how we built it. Yeah, so on the left here, we have a Clojure file. And on the right, we have our report builder in our browser. At the top, you can see our data sets called dispatchable vehicles and the result of evaluating that. And mirrored on the left side, we see it in this trace. And I can click on this plus button to make a choice from a curated DSL based off of the data. And I can build up my pipeline in a sort of interactive way this way and see intermediate results as I go. And as I add these data processing pipeline steps, you can see them also reflected in the Clojure code. And finally, we get out a plot so I can understand a bit more about the distribution of cars in our system. But how did we go about building this? The problem with live programming is it can be transient. So when I show you this artifact, or I check my code into source code, or into source control, you can no longer see how I went about building this. And when I went to Berlin, I didn't know anything about how people live program in Clojure and Clerk. And sitting with Martin and Philippa every day and seeing them live program is how I learned what that means. So we want to try to share that with you. So I'm going to pass it to Martin, and he'll show you some live programming in Clojure and Clerk.
All right, so yeah, this is Emacs on the left here, right? And on the right we have Clerk's view. So yeah, dear reviewer C, you can call Emacs many things, but I think a dead editor is not one of them. So this is Emacs connected to my live runtime. And so first kind of evaluating Clojure forms. I can evaluate the thing at the cursor. You see I get back to 41 when I'm standing here, but with a different shortcut, I can evaluate the whole top level expression, right? You see this highlighted. And I get back to 42. And I have another shortcut to show this in Clerk. And yeah, let's now try to recreate or let's first look at the data set. And I can show this in REPL, and I get this in the mini buffer here at the bottom, or I have a different shortcut and I just see that in this panel here, or I can show it through Clerk, again, with this shortcut, and this is kind of Clerk's default view, or I display this as a table, and then you get this view that we saw earlier. And that's one example of like choosing a different viewer to represent this data set. And let me do a quick detour about Clerk viewers. By the way, Glamorous Toolkit, which we just saw, was a big source of inspiration for building Clerk. And so this is kind of my favorite example showing Clerk viewers. So this is just a standard view, but I can bring in different viewers, like this number viewer here. And things will start to look a bit nicer. And like with two specific collection viewers, I get something that still, yeah, looks better yet. And this still composes kind of with Clojure's standard data viewers. So this representation of this hash map here. All right. So yeah, back to trying to recreate this pipeline that we just saw. So we kind of started out from the textual DSL and having concrete targets for what we want to build. I'm gonna map over this. You see I get completions on the keywords here as well. And do the frequencies. And then I'm gonna, so we don't have the plot function here, and I want to show you how to recreate this real quick. So I'm evaluating this and replacing it with the buffer, giving me like concrete data to work with. And now I'm going to turn this into a plot. So I think this wasn't quite right. Yeah. And get the keys. Okay, so now we have these labels here at the top, and let's turn that into a bar chart. Yeah, now we have a concrete thing of what we just saw, but it's not yet a function, right? So I'm grabbing the sample data, putting it down here, and refactoring this into a function. And so I'm naming this at the last possible point. And finally, I can kind of wrap this in a Clerk example. And then I will see kind of Clerk will show me the code and the result kind of side by side. And I could have other examples here. Like, let's see, I want to see what this is like with a very large thing. Yeah. All right, so back to our slides, which aren't quite slides yet, right? And wouldn't it be nice if they were? So we bring in the slideshow viewer, And there we go. And with that, I hand it off to Philippa.
Okay, thank you. Let's make this bigger. And where were we? We were... Oh, it doesn't work at this resolution. This sucks. Okay. So, give me a second. Okay, part 3, keeping the liveness alive. Okay, going through this experience, building the report builder, we ran into things that killed liveness for us and supported liveness for us. So one of the things that killed liveness for us is doing way too much, right? So we started with Figma mockups, and we kind of like designed the whole system from the start. And having this like largely scoped thing really resulted in 2 large reports for us and in a 2 large DSL, like this underlying data transformation DSL. And we got overwhelmed and stuck, and it was not a good place. Another thing that killed liveness was complex architecture. So this might be a Clerk specific thing, but dealing with 2 runtimes in Clerk, that is the JVM and the browser, we had stayed in way too many places, and this made it really hard to reason about the effects of a change in the system. Another thing was deadlines. So deadlines, we really wanted to have a nice, fully functional thing for the initial live submission, but the deadline really made us compromise a lot. So we fell back into console log for debugging. That's a thing you don't want to do in Clojure world. Like you want to inspect at the REPL. You want to have as much liveness as possible, and console.log did not give us any liveness. And we kind of like dropped out of this principled process. Ironically though, deadlines is also a thing that supported liveness for us. So after the initial submission feedback, we really gained clarity. So this, like the feedback really made us cut scope for the final submission. And we focused on tiny steps and bottom-up design. So we figured out no step is really too tiny. So keeping your changes tiny resulted into keeping a running system for us at all times. It made stuff inspectable for us using the REPL. And we started over with tiny reports and a tiny DSL, and working the small made it really easy for us to reason about things and be principled. So we also came up with this thing called the 20-minute rule. So if you weren't able to build something in a complete live process in 20 minutes, we kind of needed to take a step back and rethink the entire architecture. So another thing that kept the liveness up for us was starting with a concrete data structure. What that means is like you first start thinking about the UI you want to make, and then make an initial sample data structure that kind of like captures this UI. Like for us, that meant having a place that has the code, the choices that we want to show in the UI, and the results. And from that, we built the UI using Clerk viewers. And we also made sure we can always generate code from this UI data structure at all times. And from this, we kind of got into this iterative process, doing this over and over again. And this made us focus on finding irregularities and eliminating them along the way. So I'm really zooming through this now because we don't have much time. But if you read our paper, you'll find these experience boxes throughout, which you can expand, and you can read up on where we got stuck and how we felt being in that place. Okay, I want to wrap up. There's 3 things. Like liveness really makes you feel great. Like it's great for thinking fast and getting you in a flow state and feel fantastic. It's great for exploring data workflows. And if you know where to go, it really helps you get there faster. But losing liveness can also be a prompt for you to think slow again. It doesn't absolve you from actually thinking about your architecture. So if you start losing liveness, use it as a prompt to take a step back and question your architecture. And finally, we feel there's a folk culture of live programming techniques that we're not talking about enough. So often the discourse is about the tools that we use, the live programming tools, but not so much about how people actually live program in the day-to-day job, right? And I really wish we would talk about that more. Thank you very much.